Hello and welcome to Pre-Calculus. My name is Mrs. Nutter. I apologize for not being able to be there today to meet you face to face. Hopefully I will be returning on Wednesday or Thursday of this week so that we can actually meet. I do want to do a few things to get to know you and for you to get to know how the class is going to run today. So the first thing I would like to do is have you take this quizzes. I'd like to see what it is that you know about functions from Algebra 2 / Algebra 1 and geometry. I want to see what you remember. This quizzes is not going to be graded. It's just I want to see what you got. So if you would go to joinmyquiz.com and enter the code 29116541 and then take the quiz. You do have 2 attempts. I'm hoping that this takes like 5 to 10 minutes max, but I would like you to pause the video so that you can go in and take the quizzes and answer any questions. Hopefully that quizzes wasn't too bad and you were able to get a 100%. If you were not, no worries. We will take care of any missing information as we go on today. So today is Tuesday, August 30th. By the end of class, you are going to be able to write properties of graphs with correct notation. This is going to be your objective for today and tomorrow. Today I'm more concerned about you recognizing functions. However, we are going to start looking at some of the properties of graphs and writing it in correct notation by the end of class. So there's an escape room that I would like you to complete. We'll talk about that in a minute. There's a getting to know you activity. I want to make sure that you pick up the materials that you'll need for class. Expectations for Canvas and how to use it. Canvas is my MCPS Classroom. I go back and forth between saying Canvas and using my MCPS Classroom, so forgive me if there's any confusion. They're the same thing. After we look at that, we'll look at our Unit 1, Topic 1 calendar. This is the first topic that we're going to be studying for the school year, and I'll let you know when the first summative assessment will be. And then we're going to go ahead and get into properties of functions. We're going to take some notes for today. You do have some homework tonight. It's just to complete a Google slide, which is part of the getting to know you activity. So you may be able to complete it in class and not have to worry about it for homework. But just in case, I would like you to get that done today. So I do have the opportunity to go in, and if I'm back tomorrow, I would like to have an opportunity to look at some stuff and try to get to know you just a little bit. I won't be able to put faces with names, but at least I can put some activities with names. All right, so the first thing that we're going to do is an escape room. I would like you to just have one Chromebook open per table so that you are working with your table mates and you can have a discussion to hopefully help you get through our mansion. So we're going to work together to discuss answers and determine the code to escape the Postalge Mansion. Happy solving! There are 2 ways that you can get to this escape room. One of the ways is opening up this presentation, which I'll show you where that is in a minute, and clicking on the picture of the mansion. The other way, you have to do it to get to the blank notes anyway, is right here. You're going to come here and click on the escape room activity. That will get you into the mansion for the escape room. So here is your mansion. Welcome to Postalge Mansion. Please come in and enjoy some afternoon tea. So you're going to enter down here. As you enter, the door closes and locks behind you. Your goal is to escape the mansion. How do we do that? So, to escape the mansion, apply prior knowledge to solve puzzles and determine the codes to advance to the next room. There could be one room or multiple rooms to advance through to escape the mansion. Good luck. So you're going to click on the enter and you are going to come into this room. In every single room, there are going to be objects that you can click on. Notice that you get the little hand icon if you can click on something. When you click on an object, some objects are in here and you can't click on them. But when you get to an object that you can click on, it's going to give you a question And then here are some possible answers and a code matrix. So which function has a range of negative infinity to positive infinity? So if we're talking about range, we're talking about our y values. So we're looking at a graph that has negative y values and positive y values and goes on forever. So if we look at our square root function, we stop here at 0 and we have no negative y values, so that's not an option. Quadratic, same thing. It stops at 0 and we have no negative y values, not an option. Our cube root function, notice you have the name of the function here just as a reminder. Our cube root function has y values that are going positive and y values that are going negative, so there's a possibility. And our exponential has, again, no y values below 0, so that's not our option. So E is the code or the letter that we want for this room. Our keypad in the kitchen was numerical, so we have to come over here to our wheel, and our answer was E. So the code or the number for this clue is 5. So when we come back to our kitchen, again, notice there's 1, 2, 3 objects that you can, or 4 objects, excuse me, because you can click on the envelope. We just did this one. So I would highly recommend on a sheet of paper, you write down the number 5 or say envelope 5, so you know that you got the numerical code from this icon. And then you're going to click on the other icons and see what they say, and that will help you determine what order you're going to press the numbers in on our keypad. When you press the numbers on the keypad, as long as you do them in the correct order, you're going to get to a screen that says, hey, congratulations, you have escaped this room. If at any point you put in a code that's wrong, it's still going to let you put in 4 digits. Once you put in the 4th digit, and if any one of those 4 digits is wrong, it is going to say wah, 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 and take you to a screen that says incorrect. And as you go back to this screen so that you can try to figure out what the code is again. You are not going to be allowed to escape a room until you put the code in the correct order or you put in the correct code. This should take you about 20-25 minutes, depending on how much you can remember about your functions and what they look like. Every clue is going to have a graph of the function or some kind of descriptor of your function, so hopefully it will help you and you will remember. So please go ahead and pause this video for anywhere from 20 to 30 minutes to make sure that you have plenty of time to actually escape. Work with your table mates. Introduce yourself to your table mates if you don't know each other. Happy solving! I hope you enjoyed the escape room. It's a little bit different, some kind of fun activities. I like to throw in some random novel things so that you don't get bored with just sitting down and taking notes, because I know that can be boring at times. So now that we have completed the escape room, I would like to do this getting to know you activity. This assignment is a Google slide that you're going to upload in My MCPS Classroom. You're going to find the rubric and directions linked on our homepage as well as in the class notes. On this slide, you're going to be putting your name, your preferred name if it's different than your gradebook name. I need to see both of them so I know who you are and then what you prefer to be called. I would like some pictures that represent what you did this summer. Pictures and words describing where you see yourself in 5 years. Some of you are sophomores, juniors, and seniors. What do you expect to be doing in 5 years? I would also like pictures and words describing what a good student looks like, sounds like, and feels like in a classroom. Words that describe what a good teacher looks like, sounds like, feels like in a classroom. I'm assuming one of the key components to a good teacher is actually being in the classroom. I promise I will see you at some point this week. A sentence or two letting me know anything you believe is important for me to know about you as a student. So please feel free to divulge any information that pertains to you as a student. So to get to this getting to know you activity, again, come to our homepage in My MCPS Classroom. Scroll all the way down to the calendar down here at the bottom and complete this getting to know you slide. I'm going to click on it. It's not going to be open until 7 o'clock tomorrow morning, which is fine. Here you can see the criteria or the rubric, so you know how I will be grading you. And I will put in your marks as we go. So you get a point for your name, 2 points for letting me know what you did this summer, 2 points for your 5-year goal, 1 point for a good student, 1 point for a good teacher, and then anywhere from 0 to 3 points for your sentence describing something I should know about you. So please be brutally honest. This should take about 15 minutes, maybe 10 to 15 minutes, I'm thinking. And this is the activity that if you don't get it completed in class, then the expectation is that you will complete your slide and upload it for homework tonight. Notice that it is 10 points. Here's your first grade of the marking period. Crazy. All right, please let me know something about you. Thank you for letting me know something about you, some interesting facts about you so that I have something to come to class with. So there are some materials that you'll need for class. Notice in the center of the screen there is a pre-calculus packet and there is an assignment sheet. Those are both over on the table as you walked in the classroom. It's a pink packet and a white piece of paper right next to it. You can also find those in our Google folder, which I'll show you where you can access that in a minute. I would also highly recommend having a notebook or at least some loose leaf paper if you prefer having a 3-ring binder designated for math. There are going to be some activities that we do that are not necessarily going to be in your packet, and I would like for you to have the opportunity to write those down in your notebook. You may also want to or choose to take notes just in a notebook during class and using the packet as a, let me see if I remember what we learned in class today, where you always have our slides to be able to go back to and fill out the pre-calculus notebook or packet, excuse me. It all depends on how you would like to take your notes for the class. Obviously, you need pens and pencils. You will eventually need a calculator for the class because we are going to work with some functions that will be graphing them and doing different things with the calculator. However, for this first topic, it's actually no calculator. This is something different than any of the other math classes that you have taken. There will be topics or units at times where you're not allowed to use calculators, and it's not our decision. There's assessments that come from the county that tell you that you cannot use a calculator. If you are a special ed student and you have a calculator accommodation, you will be provided with a 4-function calculator for assessments because even though it says no calculator, you are allowed to have a 4-function calculator. If you do not have that accommodation and you have no idea what I'm talking about, you are not allowed to use a calculator. Apologies for any inconvenience that may create. All right, Canvas expectations. This is what your homepage looks like. We've already looked at it a couple of times. But homepage is where you will find everything. If you would like to look at your syllabus, you can click on this and your syllabus is uploaded there. We will spend some time going through the syllabus together to make sure that you understand everything that's there, but for now, if you want to, you can go look at that. If you would like to email me, this takes you to the email that I am most likely to respond to from students and parents. I would check that email in the morning and I'll check it in the afternoon. So you will have access to me and I will get back to you as soon as I possibly can. So Google Drive folder. This is where you can find a copy of PDF notes, anything that we take during class, and a blank copy of the packet. Miss Weiss is the one who actually uploads her notes that she takes during class here. So the notes there are going to look a little bit different than what we do in class. If for any reason we need to Zoom together, whether we're conferencing, whether you are home and you don't want to miss class and you would like me to Zoom with you, we can do that. This is actually the link to it, but in case the link doesn't work, here is the number and the passcode is Nutter. This part of the home page are all of the topics that we will be covering in the first marking period together, or excuse me, first semester that we will be together. And below that is a calendar. These are all of the weeks for semester marking period, goodness gracious, excuse me, for marking period 1. The objective for each day will be written on top of here. And then we will always have your lesson video or notes, all depending on what happens. If I'm here, then it's going to, or if I'm not in class, then it will be a lesson video. If I am in class, then it'll just be a PDF of your lesson notes. And if you have homework, it'll be down here. This will signify what your homework is. Notice you have homework on all of these days, which is fine. Homework for tonight is just to complete your Google Slides. Most of your homework is going to be out of your packet. Please expect homework to be checked most days. So that's everything you need to know about the Canvas page. If you need to find anything, or My MCPS Classroom, if you need to find anything, it is all right here on the home page. Oh, if you do have assignments that are, or homework that are in Canvas, the link will be right here, or you can come over here and click on assignments. Either way, it's up to you. But that's everything you need in My MCPS Classroom. All right, Unit 1, Topic 1 calendar. This is also saved in the Google Drive folder here. If you go to your calendar, it will also be saved on your calendar, or you can just look at the week down here. But again, you should have a hard copy of this, and you should have picked it up on the table as you came in. Notice that there are YouTube videos already embedded, or a video over here for certain topics. Please feel free to watch those videos to help at any time as well. All right, so turn to page 2, I believe it is, in your packet, and we're going to talk about these functions. You've already looked at all of these functions with the escape room and with the quizzes, but now I'd like to have a solidified place where you have everything written down. So if you have an S-shaped curve that expands over the whole graph, this is going to be your cube root function. Okay, your range is all real numbers, or from negative infinity to positive infinity. Your domain is all real numbers, from negative infinity to positive infinity. A curve that goes upwards and has one asymptote. An asymptote, remember, is a line that your function cannot cross. That will be an exponential function. So we used cube root, we used exponential. Here you're going kind of in the opposite direction, but notice that your asymptote is a vertical line instead of a horizontal line. So that's actually the inverse of an exponential function, which is a log function. You studied those in exponential, you studied in Algebra 1 and Algebra 2. Logarithmic, you started studying in Algebra 2. This cube root you should have seen in Algebra 2 also. Over here again, we have an S-shaped type curve, only this time it's rapidly increasing from left to right. So this is your inverse of cube root, which is your cubic function. Here we have a trig wave that I say that it starts here above your origin. So this is going to be your cosine graph. And the one that passes through your origin is going to be sine. Sine and cosine. Here we just have a straight line. Bam, ba, da, ba. It's right in the name. It's linear. Linear. Here you have two linear lines. However, they make a nice little V. That's going to be your absolute value. Here we have two curves that never touch each other, and they are in opposite quadrants, or diagonal quadrants, I guess you could say. This is one of the versions of a rational function. There are two types of rational functions that you have looked at. This is a rational function, and this more specifically is the y equals 1 over x rational function, because they are in diagonal quadrants. So just know that, I mean, I believe you saw them in the escape room. There are two different types of rational equations that we will be working with some. This is our good old friend quadratic from Algebra 1 and Algebra 2. We spend a lot of time talking about transformations and such with your quadratic functions. And this is the inverse of a quadratic function, which is your square root function. I don't expect you to have all of this stuff memorized tonight. However, I do expect within the next week or two that I can say a function, a name of a function, and the generic shape of that function comes to mind. Here we have curves that have multiple vertical asymptotes. This is the last trig function that we have spent time looking at in Algebra 2 and in geometry, actually, and this is your tangent function. Okay, so those are all of your basic functions. Yes, it's a lot of functions. You have spent a lot of time looking at all of these functions in Algebra 1 and Algebra 2. Pre-calculus takes everything that you learned in Algebra 1 and Algebra 2 and expands on that even more. A lot of people like to call this your Algebra 3 course because it's really just a lot of algebra. Okay, let's review some other properties. All right, so properties that we talked about with the escape room and the quizzes, you have domain and range. Domain are your x values and range are your y values. You have increasing and decreasing. When they're talking about an interval, they're always talking about x values. Okay, so intervals, x values, intervals, x values. So if I want to know the increasing interval, I want to know what x values is my graph increasing on. If I want to know the decreasing interval, what x values is my function decreasing on. Interval notation versus inequality notation. I have a feeling that most of you have used this type of notation, which is your inequality notation from Algebra 1 and Algebra 2. Some people in Algebra 2 may have started using this. So if I have the interval notation -3 is less than x, less than 7, to write this with interval notation, because I do not have equal to, I just have less than here, I'm going to use parentheses and say -3, comma, 7. So this tells me my lowest x value is -3, my highest x value is 7, but it's going to be open dots at both of those because my function is not equal to them. If we have something like y is greater than or equal to 10, your interval notation is going to use a closed bracket at 10. So I can have any value from -infinity to 10, and then I stop. Oh, excuse me, that's going to be positive infinity. That's not right. So if I have y greater than or equal to 10, it's actually going to be 10, and then y is greater than 10, so it's going to be positive infinity. Sorry, I wrote that the wrong way. Okay, so interval notation versus inequality notation. I'm not going to be upset with you for now if you still use the inequality notation. Just know that most of the stuff that you find or the quizzes or worksheets or whatever that you have will most likely be using interval notation. So you do have to get to know the different type of notation. And then we have end behavior. I know that you touched on this in Algebra 2. Again, Algebra 2 had a lot of information in it, and pre-calculus is expecting you to know all of that information. However, we will work with you and have the information come up to the forefront of your minds before you get tested on any of this stuff. End behavior is talking about what is going on the ends of our function. So if we're talking about left end behavior, we're talking about what's happening to the function as it approaches negative infinity. So let's say, for example, we have our cube root function that looks something like this. It's not a very good one. Hold on. We have our cube root function that goes something like this. Oh my gosh, this is not working out. All right, let's go back to the easiest one and go to quadratic. All right, here's our quadratic. So left end behavior is talking about what is going on as I'm looking at my function this way. So as my x values are getting closer and closer to negative infinity coming out this way, my y values are continuing to increase, 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 increase. So the notation for this is as x approaches negative infinity, my f of x values, g of x values, it doesn't matter, my function values are approaching positive infinity because my y values are increasing as my x values are getting negative, more and more negative. If you're looking at the right end behavior, you're describing what is happening to the function as it approaches positive infinity. So that means right end behavior is this side of my graph, and I'm starting in the middle or at 0 or wherever makes sense, and I'm looking at what's happening as my x values are getting bigger and bigger and bigger. And here it has my y values increasing, increasing, and increasing. Notation for this says as x approaches positive infinity this time because it's on the right hand side of our graph, my f of x values are also approaching positive infinity because my graph is going upwards. My y values are increasing as well. Okay, so it's very important that you put this whole thing down when you're writing end behavior. Make sure that you have as x approaches either positive or negative infinity, f of x is then approaching whatever f of x happens to be approaching at that time. More vocabulary to review. We have maximums, minimums, absolute versus local minimums, absolute versus local maximums. So obviously a maximum means your highest point or your highest y value. Your minimum means your lowest y value. But there is a difference between absolute versus local minimum. Absolute means that it is the absolute lowest y value that you can have on your graph. A local minimum means that it is at the point or at a point that is lower than other points surrounding it. Same with your absolute and local maximum. Absolute maximum is the highest maximum on the graph. Your local maximum is a point that is higher than the other points surrounding it. So if you look at the graph that we have down here, when you come to this point, this is a maximum because it's at the top of a curve. However, we have a point that's higher than this one on our function. So this is just a local maximum. Because it's not the highest point on our graph. However, this is the highest point on the graph, so this is our absolute maximum. Sometimes you'll have a local and an absolute maximum or minimum. Other times you may just have a local or an absolute. Here, because our function continues going down on both ends, this is just going to be a local minimum. It's lower than the surrounding points, however, it is not the lowest point that we can possibly have on our graph. So it's just considered a local minimum. On this graph, we have 3 very specific points. Here, we have a local minimum because it is the bottom of this curve. However, it is not the lowest point. So this is a local minimum. B is at the top of a curve. However, it is not the highest point that we have. If there are no arrows on the end of a graph, we're going to assume that there are arrows there if there's no specific point ending it. So here is a local maximum because it's a higher point than the points that are surrounding it. However, it is not the highest point on the graph. And here we have an absolute minimum because it is the absolute lowest point we can get. I don't know why it doesn't write all of the letters. Every time. Okay, so that's your absolute minimum. Okay, this is a new property that we haven't studied in Algebra 1 or Algebra 2. It's called boundedness. This is a pre-calc concept. So this is the additional information that you're getting from all of your algebra information. So boundedness, and I don't mean to insult your intelligence, but I am going to read this to you because it's important. Graphs that have an absolute minimum or maximum are considered to be bounded functions. Functions with an absolute minimum are bounded below. So that would be a great piece of information to highlight or underline in your packets. Absolute minimum is bounded below. Functions with an absolute maximum. Another great thing to have underlined or highlighted in your packets, absolute maximum, are bounded above. Functions with both an absolute minimum, and maximum are called or are bounded above and below. I don't know why it just has the word called. So they're bounded above and below. We are going to get rid of this and I'm going to text it or type it because it's easier. Okay, so they're bounded above and below. So if we talk about being bounded above means that you're going to have an absolute maximum. So your graph, an example of that is a quadratic that is upside down because you cannot have anything above this maximum point. So this is going to be bounded above. Function that can be bounded below, again, could be a quadratic, or we can do a square root function that goes this way. Bounded below because this is a minimum. an absolute minimum. So it's going to be bounded below. It can't have anything down here. If it's bounded above and below, a function that has an example of this is either your sine or your cosine function. I am just going to put a wave on here. I'm not going to make it specific, go through anything in particular, because it can be a it can be a transformation of one of those two, so it doesn't matter. But this is bounded above and bounded below because you have absolute maximum, absolute minimum. All of these minimums are at the same exact point, so they're all absolutes. All of the maximums are at the same exact point, so they're all absolutes. That's how it works with the cosine and sine wave. A function that has no boundedness, an example of this is actually your tangent function, because it goes forever in every direction. Obviously, this is not a perfect tangent graph, it is just a sketch. But there is no local max and there is, or absolute max, and there is no absolute minimum, so there is going to be no boundedness on this function. And please at any point pause the video if you need to write stuff down or go ahead and rewatch. Okay, last piece of information that we are going to do today is just review some of your properties. So find the requested properties of each graph. Use interval or set notation. Note when a graph runs into the border of its window, the graph continues. So always assume that your graph is continuing. All right, I like to use blue because it's easiest, it's bright, and it's easiest to see. So this is a quadratic function. Quadratic functions have a domain of all real numbers and a range of all real numbers. I'm going to write down the interval notation just so you start to get used to it. So the domain comes from negative infinity, goes all the way to positive infinity. Infinity is not a number that you can equal because it just is a number that's going on forever. So we use parentheses instead of the closed bracket. Your range is not the same thing. Your range for this function goes down to 1, 2, 3, 4, -5. So it's equal to -5. So we're going to make that a bracket, -5. And it goes on forever in the upward direction. So we go up to infinity. Your minimum point is 0, -5. Notice that this looks very similar to your interval notation. You just kind of have to know what you're talking about, know the context of what you're dealing with. Maximum, there is no maximum. There's none. Increasing, decreasing. This means increasing interval, decreasing interval. So when I'm looking at my graph, when we want to do this part, we always read our graph from left to right. So when I look at my graph going left to right, this side is going down. When I look at this side of my graph, we are going up. So this side is decreasing. So that's my decreasing interval from negative infinity, remember their x values, to 0. Because we stop decreasing at 0. So then my increasing interval is going to start at 0. It can equal 0, so we put a bracket on there. And it goes to positive infinity because my x values keep going. Boundedness, I have a minimum point, so my graph is bounded below. Right end behavior, left end behavior. I'm going to change the color of this because I'm also going to put arrows on my graph for this. I'm going to use red. I hope nobody here is colorblind. I apologize if you are. Right end behavior means what is happening to my graph as I go this way. So as x approaches positive infinity, my f of x, or my y values, are approaching. So as I look at the right side of my graph, my x values are increasing, my y values are also increasing. So we're approaching infinity. Left end behavior, this is where it gets confusing with our intervals, because left end behavior, I'm actually going to read or look at my graph going in this direction. So what happens with my graph as I'm looking at the negative side of my x values? So while I'm looking at the negative side of my x values, I notice that my y values are actually increasing. Even though it's on a decreasing interval, I'm not reading for end behavior, I'm not reading from left to right. If I'm looking at left end behavior, I'm actually reading it from the right to the left so I can see what's happening when I get to the end of my function. So to write that, we say as x approaches negative infinity, our f of x, or our y values, are also going to approach positive infinity. Both sides of my graph are increasing, so I'm approaching positive infinity. All right, let's get some different colors in here. So we have a square root function. You should know that it's your square root function because you have an endpoint and then a curve that slightly goes up. It could slightly go down too, but this is a square root function. So domain for your square root function is going to come to this point as your endpoint. So that's 1, 2, 3. So we can have a value of -3. And then our graph continues on to the right. So it continues to positive infinity with a parenthesis on the end because you can't equal infinity. Our range is going to count down to this number. So we have 1, 2. So our lowest y value is going to be -2. And our highest y value, again, we're curving up. So our y values are going higher and higher and closer to infinity. We have an absolute minimum because we cannot go any further down than this point. So -3, -2 is our minimum. And there is no maximum. Increasing interval, we only increase, so whatever our domain is going to be our increasing interval. So from -3, we can equal -3, so use your bracket, comma, infinity with a parenthesis, you can't equal infinity. Decreasing interval, there is none. Please do not write 0, please do not leave it blank. Actually write in none so I know that you know that there really is not a decreasing interval. Boundedness, I have an absolute minimum, so that means I'm again bounded below. Right end behavior, I'm going to change the color for this one. So right end behavior as x approaches positive infinity, you always have to write this part down. You will get points off on any test or quiz if you do not write that down. So as x approaches infinity, f of x or the y values are going to also approach infinity, because when we look at the right-hand side of our graph, our y values are increasing. So we're going to infinity. Oops, you don't need to have this on the end, I'm sorry. Left end behavior as x approaches negative infinity. Oh, wait, our graph doesn't approach negative infinity. So we have no left end behavior. We say negative as x approaches -3, our f of x values approach -2. So your left end behavior is different. Excuse me when I said that you don't have a left end behavior. You do have a left end behavior. You're just not approaching negative infinity. Your x value doesn't go past -3, so that's what you're going to approach for your end behavior. And when you're at -3, your y value is -2. So as x approaches -3, your f of x value is going to approach -2. All right, so I know that there are more pages and more problems to do in our packets. However, I would like to take a mental break at this moment in time and remind you that your homework is to complete your Google Slide assignment, which is in Canvas, and explore the Canvas page, see what you find. I would highly recommend looking over the syllabus, seeing if you have any questions about that. Again, I should be back in class on Wednesday. At the latest, I'll be back on Thursday. It all depends on how things go here. So I hope that you enjoyed this lesson, and I will see you in person shortly.